Okay, hey, here we're looking at an integral. It's the integral of tangent of 3 halves x times secant of 4 to the fourth x. Now, with this, we're going to use our trig not trig substitution. We're going to use some trig identities, right? With these multiples of different trig functions here. So with this, we're going to separate our secant fourth to secant squared, because you're going to want to save one of these secant squareds, okay? Now, secant squared x is 1 plus tan x, and tan squared x. That's a trig function. Then choosing this substitution over here, you're going to make u equals tan x. Now you differentiate this equation here. So du equals the derivative of tan x is secant squared x dx. And that's why you saved that secant squared in the previous step, is so that you could sub out the dx for a du by bringing also this secant squared. So notice secant squared x dx becomes the du due to this formula here. And then all of these tan x's become u's. So tan 3 halves x becomes u 3 halves. 1 plus tan squared is 1 plus u squared. Now I'll distribute my u to the 3 halves in. U to the 3 halves times 1 is u to the 3 halves. U to the 3 halves times u squared is u to the 7 halves. And now I'm going to integrate. I'll integrate each of these terms. So take this 3 halves, increase it by 1. So 3 halves plus 1 is 5 halves. And then I'll divide by 5 halves, or multiply by the reciprocal, or 2/5. Same thing here, 7 halves increased by 1 is 9 halves. And I multiply by the reciprocal, or 2 over 9. Then I'll add my c. And here's my solved integral, but you'll want to resub back in the uh, u's as tan x's there, okay? So there we have it. Looks like a nice little solid integral, and there you go. Okay, let's see if we can stop there it is. How do I stop this? No. Stop.